Hi, I'm just going to talk you through the answers to this home learning mat just so you can get your last bit of revision in. So let's just see what we can come up with. So current is measured with an ammeter, okay, which must be placed in series in a circuit. The voltage is measured with a voltmeter, okay, which must be placed in parallel with the component you're measuring. Okay, let's look at the circuit problem. I think this is the bit that some of you are struggling with. So we're going to use the key equations and the current and voltage rules of series and parallel to find all of the readings on all of the meters. Okay, and we're going to look at how we get our answers. So we know the potential difference given by the power supply is 12 volts. We want to find the current and we want to find each of these are being given. So the first thing to do is to find the current. So we know that current, total current, is going to be equal to the power supply voltage divided by the total resistance. So the voltage is 12 volts. Now the resistors are in series, so they're next to each other. So the total resistance is going to be what those resistors are added together. So basically 60 plus 60, which is 120. Okay, so 12 divided by 120, okay, is going to be our current. So on your calculator, all you need to do here is 12 divided by, 12 divided by 120, okay, which gives me 0.1. So I know that in a series circuit the current is the same all the way around, and I now know that that is 0.1 amps. What I then want to find is the voltmeter reading across this. So I'm going to rearrange my equation to find voltage. So V equals IR. I know the current stays the same, 0.1, and I know that the resistance is 60. So I'm going to do 0.1 times 60, which is 6 volts. We can do the same thing here, but the resistances are the same and it's got 12 volts here. So I know that this is going to be 12 minus 6 will give me this one, because 6 plus 6 equals the 12 from the power supply. Okay, hope that makes sense. Right, let's have a little look at this bit. Circuit symbols. Draw below the symbols for the following devices. So we've got a diode, which is an arrow with a line on one side and a circle. We've got a thermistor, which is a resistor with the line through it. We've got an LDR, which is a resistor, light dependent resistor, so the light shines on it with the two arrows. An LED is a diode, so it's the diode symbol, but it gives out light, so you draw the arrows coming out. Filament bulb, and a battery, which is 2 or more cells. So there's a battery. Positive, negative, positive, negative. Okay, let's have a look at these equations then up here. Key equations you must know. So voltage is measured in volts, current is measured in amps, resistance is measured in ohms. And just draw that a bit clearer there. There we go. Power is measured in, this mine's very, very small, I'm just going to write it next to it, watts. Current is measured in amps and voltage is measured in volts. It should say potential difference though, which is very naughty that it doesn't. Okay, charge is measured in coulombs, current is measured in amps, and time is measured in seconds. Work done is measured in joules, voltage is measured in volts, should say potential difference, charge is measured in coulombs. We can write the 4 equations above in triangles. So the first one, we would have V, I, and R. I'll just get a bit closer on that one. Okay, V, I, and R. Second one, power is current times potential difference. third one, charge Q equals IT, looks like quit. And the last one, work done. So you can do energy or work done. I'll do, I think I'll just do energy because it's measured in joules, but work done is potential difference times charge. Okay? Right, last part. Let's have a little look at these. In series circuits, what's the same everywhere? Okay, it's the current. And I think that's supposed to say of. So the potential difference of the battery is shared across components. In parallel circuits, then, the PD on each branch is the same, so the potential difference in the branch is the same as the PD from the battery. And the current of the battery is the sum of all the currents in the branches. So all that means is, like, if you split your currents up here, when you add them, they'll all add back together here, and then the current that goes through the battery is the total. That's all that means. So if you split them up here, it joins back together here, and then the sum of them all goes back to the battery. So if this was 1 amp, 1 amp, 1 amp, the sum of that is 3 amps, and that's what would go to the power supply. Okay, for this last one, we're looking for the graphs. So we would say this one is Ohm's law. It's a straight line through the origin. Okay, this is a bulb or a filament lamp. So initially, as you increase PD, you increase current. Okay, but the current level's off. Okay, because the temperature increases. And the last one, the diode, okay, in one direction, so remember one direction, that's why we listen to them, there is no current, and in the other direction you need a high enough PD to get current. And after that it's a straight line, so it'll follow Ohm's law. Right, I hope that helps you fill in and just do your last bits of revision for your test tomorrow, okay?